Imagine standing at the edge of a vast and ancient darkness, where the sun has shrunk to merely a bright star amid countless others. The cold here is not sharp or frightening, but rather a deep, settled calmness, the kind of cold that seems to belong to silence itself. Around you, the solar system stretches in its great spiral architecture, and somewhere in this twilight realm between the inner planets and the infinite void beyond, there exists a world so peculiar, so gently strange, that it seems almost to be dreaming in the darkness. This world is tilted almost impossibly on its side, rolling through the cosmos like a ball that has been laid down to rest. Its surface, if you could somehow float above it, would reveal not rock or fire, but a subtle, serene blue-green, as if twilight itself had been frozen into a sphere and set spinning in reverse. What would it mean for a planet to rotate not from north to south, but from east to west, with its poles lying almost horizontal to its orbit? How would time itself feel different in a place where the sun remains nearly invisible for decades at a time, and where a single day lasts longer than many human lifespans? This is Uranus, the seventh planet from the Sun, and it has been waiting in the outer darkness for some 4.5 billion years, keeping secrets that we are only beginning to gently uncover. Before we drift deeper into its mysteries, if you're drawn to the strange and peaceful beauty of Uranus, to worlds that challenge what we think we know about how the cosmos arranges itself, consider subscribing, so that as we explore these relaxing facts about Uranus together, you'll never miss a gentle passage through its quiet wonders. Now, imagine yourself leaving the familiar warmth of the inner solar system behind. The rocky planets with their mountains and storms and violent histories begin to fade into the distance. The asteroid belt, that scattered ring of ancient debris, passes like a whisper. Mars, with its thin red atmosphere, recedes. The great Jupiter, with all its chaotic turbulence and roiling clouds, grows smaller and then smaller still. Saturn, with its magnificent rings catching the distant sunlight, becomes just another star. The sun itself, which began as a warm and vivid disk when you started this journey, has now become merely a bright point of light, no stronger than Venus appears from Earth's evening sky. You move deeper still, outward bound, into regions where the solar wind grows thin and the darkness begins to overwhelm the light. The temperature drops steadily, not in sudden increments, but in a long, gradual descent. Your surroundings take on a color that is almost blue-black, a darkness so complete that it feels less like the absence of light and more like the presence of something ancient and patient. And then, gradually, you become aware of movement ahead of you. Not movement toward you, but a slow, deliberate rotation, a shape, a world. At first it is merely a silhouette against the star field beyond, but as you approach, details emerge like a photograph, slowly developing in chemical darkness. The sphere reveals itself in shades of cyan and pale blue-green, a color as if all the water and ice of Earth had been separated from the rock and suspended in the void, then painted with the last light of a sunset that will never fully arrive. The surface is smooth, almost featureless from this distance, yet it carries a sense of profound depth. Layers beneath layers, mysteries stacked one upon another. What makes this world so beautiful is not dramatic peaks or violent storms, though those things exist here too. Rather, it is its quietness, its stillness, its acceptance of being so distant from the sun that warmth is almost a theoretical concept. This world has been turning slowly in the void for billions of years, asking nothing of the cosmos, offering its secrets to anyone patient enough to listen. This is where we are going. This is Uranus, and for the next little while, we will drift closer and closer to its mysteries, learning what makes it so peculiarly, so perfectly, relaxing to contemplate. The great distance of the outer solar system seems to stretch time itself. You are not rushing. There is no urgency here. The journey unfolds at the pace of starlight, which is to say at the pace of deep thought, of memories forming, of breath deepening and becoming more regular. Around you, the darkness thickens pleasantly. The temperature of your consciousness seems to cool as well, matching the coldness of this distant realm. It is perhaps 20 times farther from the sun than Earth is, and in that distance, something fundamental shifts. Time moves differently. Seasons last decades. Gravity tugs gently at vast stretches of ice and hydrogen, and through it all, a kind of profound patience settles over everything. You approach the plane of Uranus's equator, and something remarkable becomes apparent. Most planets in our solar system rotate like spinning tops, their poles pointing upward and downward relative to the flat plane they orbit in. But Uranus does not obey this expectation. Instead, it lies on its side. Its north and south poles point roughly toward the sun and away from it, respectively, as if it had been gently tipped by some ancient hand and then left to spin that way for all eternity. The effect is hypnotic, almost dreamlike. Imagine Earth if it rolled forward into its orbit instead of standing upright. Imagine how the sun would rise not from the east and set in the west, but from directly overhead, then moving lower and lower until the entire planet plunged into darkness that would last for decades. This is the reality of Uranus, and somewhere in that strange geometry lies a story of violence and transformation so profound that it reshaped an entire world. As you hang there in the cold darkness, watching this tilted blue sphere turn in its slow, patient rotation, you begin to feel the weight of time itself. Uranus takes 84 Earth years to complete a single orbit around the Sun. 84 years. That means each season on Uranus lasts more than 20 years. Think of that. Spring, as it exists on Uranus, would extend across the entirety of a human generation. A child born at the beginning of Uranus's spring would grow to adulthood, have children of their own, perhaps see grandchildren, all while the same season continued. The sun would be no brighter at the end of those 21 years than it was at the beginning. The ice would remain just as cold. The wind would blow with the same slow constancy. There is something deeply peaceful about contemplating such vast stretches of time. On Earth, we measure our existence in days and months and years, in seasons that cycle every 3 months or so. We are accustomed to change, to the perpetual rotation of light and dark, warmth and cold. But Uranus moves to a different rhythm entirely. It is a world that teaches patience to anyone willing to listen. It is a world that has learned to accept the slow passage of eons as if they were merely heartbeats in a longer sleep. And now, as the blue-green sphere grows larger before you and the details of its atmosphere begin to resolve, you find yourself falling deeper into a kind of cosmic stillness. Your breathing has slowed. Your thoughts have become gentler, more spacious, less hurried. The cold that surrounds you is no longer a threat, but a presence, almost a companion. The darkness is no longer empty, but full of quiet possibility. And Uranus, tilted on its side, spinning its slow rotation, seems to invite you into its gentle mystery. This is the moment when we begin. This is where the story of Uranus truly unfolds. And you, suspended here in the cold and the dark, watching a world that has kept its secrets for 4.5 billion years, are ready to hear them. The ancient astronomers who mapped the night sky did so with eyes attuned to patterns invisible to us now. They traced the wandering paths of the brightest celestial bodies, Mercury, Venus, Mars, Jupiter, Saturn, and named them with reverence, watching as these luminous travelers moved against the seemingly fixed field of stars. For thousands of years, Saturn held the edge of known creation. It was the final great world, the guardian of the solar system's boundary, and beyond it lay only the unreachable ether and the countless fixed stars deemed eternal and unchanging. The universe had its limits, or so it seemed. On the night of March 13th in 1781, in the garden of his modest house in Bath, England, a musician turned astronomer named William Herschel was conducting one of his patient, methodical sweeps through the heavens. He had constructed his own telescopes, remarkable instruments that he ground and polished by hand, teaching himself the craft through years of careful practice. Tonight, he was mapping what he believed to be the familiar stars of Gemini, working through the darkness with the kind of unhurried attention that characterizes the most significant discoveries. There was nothing urgent about the moment, no anticipation, just the quiet work of cataloguing light. And then, something subtle shifted in his awareness. Through the eyepiece, among the pinpricks of distant suns, a small greenish disk appeared, a tiny circle with substance, with dimension, with presence. It was not a star. Stars, no matter how bright or how close they seemed, remained points of light. This was different. This was a world. Herschel noted the object, made his measurements, and continued his sweep. He suspected it might be a comet, that occasional visitor that sometimes ventured into the inner solar system on mysterious trajectories. He recorded the position and moved forward through the night. In the following weeks, as the object continued to move through the sky in patterns that were inconsistent with known cometary behavior, a quiet realization began to crystallize. Other astronomers across Europe, in Paris, in Berlin, in Russia, turned their telescopes toward the same patch of sky. The calculations were checked and rechecked. The mathematics was unmistakable. This was not a comet at all. This was an entirely new planet, a seventh planet, a world that had been gliding through space all along, just beyond the reach of human awareness, waiting in the dark to be noticed. Consider the vastness of what this meant. The solar system, which had seemed so thoroughly mapped, so complete in its architecture, suddenly expanded. The known universe grew larger in an instant. Everything that astronomers believed about the scale and structure of the celestial realm had to be revised. The boundaries had not been where anyone thought. There were more secrets waiting in the outer reaches. There were worlds we had yet to find. William Herschel received the honor of naming his discovery, and the scholarly world held its breath to see what he would choose. Some proposed Herschel, a name that would forever attach the discoverer to the discovered. But Herschel declined the honor, preferring instead to look backward, to reach into mythology and antiquity for a name that would resonate across the ages. He selected Uranus, the primordial sky itself, the oldest and most ancient of the classical deities, the progenitor of all other gods in the ancient pantheon. It was a fitting choice. This newly revealed world was called after the cosmic principle of sky, the very fabric of the heavens, and in naming it so, Herschel wove together the old and the new, the mythological and the scientific. The greenish disk had a name now, and with that name came a new chapter in humanity's understanding of the cosmos. The night sky that had seemed so stable, so thoroughly known, revealed itself to contain mysteries still waiting. Uranus hung in the dark beyond Saturn, a silent wanderer, patient and calm, having circled the sun billions of times already without fanfare or notice. And it would continue its slow journey through the ages, drawing ever closer to astronomers and dreamers who wondered about the secrets hidden in those unreachable blue-green distances. Once the news of this unexpected discovery began to spread through the astronomical community in those final months of 1781, a quiet but earnest debate unfolded among the men who studied the heavens. What would they call this interloper that had suddenly appeared at the edge of the known universe? Herschel himself, in the first flush of discovery, had proposed the name Georgium Sidus, the Georgian star, a gesture of respect toward King George III, who had been his patron and whose reign had blessed this moment of revelation. But there was something almost reluctant about how other astronomers received this suggestion, a gentle resistance that rippled through observatories across Europe. The name felt too earthbound, too rooted in the politics of courts and crowns, for a world that belonged to the ancient heavens themselves. And so the naming evolved slowly, thoughtfully, across months and years of quiet correspondence and scholarly discussion. There emerged among the learned men a growing inclination towards something far deeper, far more resonant with the classical traditions that had always governed the naming of the wandering stars. Why not, they began to ask one another, follow the precedent set by the other planets? Why not reach back into the tapestry of ancient mythology, where the sky gods and cosmic forces had long resided in human imagination? Why not grant this newfound world a name that spoke to eternity rather than to the moment of its discovery? In the mythology of the ancients, those distant peoples who had gazed at the same stars we gaze at now, though they understood them so differently, there existed a primordial figure, a being so old and so fundamental that even the great gods who came after him stood in some relation to his immense presence. This was Uranus, the personification of the sky itself, the original sky god, the grandfather of gods, the father of titans. In the ancient accounts, Uranus emerged from chaos alongside Gaia, the earth, and together they represented the two great primal forces, the boundless sky stretching overhead and the solid ground beneath. What could be more fitting, the astronomers reasoned, than to name this distant, mysterious, pale blue-green wanderer after Uranus? What could be more apt than to call it the sky, continuing the family of names inherited from Jupiter, Saturn, Mars, and Venus? There was a particular poetry to this choice, though perhaps most of those who made it did not dwell on it consciously. The father planets had always been the slowest, the most distant, the most mysterious, and Uranus, in mythology, was ancient even to the ancient world, a figure from the very oldest stories, often relegated to the background of later tales, less vivid than his grandson Zeus or his great-grandson Poseidon, but no less foundational. He was the beginning, he was the sky. He was that immense, indifferent expanse that stretched infinitely above all terrestrial concerns, and in naming this new world after him, the astronomers were affirming something true, that this pale wanderer belonged to the deep orders of the cosmos, not to the immediate concerns of kingdoms and kings. By the year 1784, about 3 years after Herschel's sighting, the name Uranus had gained enough traction that it became, gradually and almost without fanfare, the accepted designation. It was not announced with great ceremony, nor was there a formal decree. Rather, it simply became the name that appeared more and more frequently in astronomical papers and charts. And how curious it is to imagine those astronomers, working by candlelight in their observatories, quietly adjusting their notations, their records, their star catalogues, settling upon this name drawn from the very first pages of mythology, from the time before time in the stories of the ancients. Yet even as they named it, even as they fixed it in the language and literature of astronomy, a profound uncertainty remained about this world. What was it, really, this Uranus? Was it a planet? The evidence seemed to suggest so, but confirmation would require time and further observation. Was it hollow, as some speculated? Was it solid or gaseous? How far distant was it truly? What forces governed its motion? These questions hung in the intellectual air like mist, unresolved, patient, waiting for centuries yet to come to provide answers. The naming itself, then, becomes an act of faith, a declaration that humanity had encountered something real enough to deserve a name drawn from the deepest wells of human consciousness, but also something that would continue to resist full understanding for a long time to come. This quiet confidence, this almost meditative certainty that a name carried the weight of discovery, even if the nature of the discovery remained mysterious, perhaps says something true about the way knowledge works. We name things not because we fully understand them, but because we have recognized them as important, as permanent, as worthy of remembrance. And in calling this distant world Uranus, in choosing the name of the primordial sky, the astronomers were making a statement that would echo through the centuries that followed. Here is something vast, something ancient in its significance, something that belongs to the order of the cosmos itself. The name would outlast all the early theories about what Uranus truly was. The name would remain steady and true long after other ideas had been replaced by better ones. And in that permanence, in that quiet fidelity to an ancient tradition of cosmic naming, there is something restful, something almost cradling, the sense that even when we do not understand a thing completely, we can still honor it with a fitting name. There exists among the planets in our solar system a world that spins in a manner profoundly unlike all the rest, and this peculiarity is perhaps the quietest, most haunting mystery written into Uranus itself. Imagine a child's spinning top, set to twirl upon a table, only to be gently tipped onto its side so that it rolls rather than stands upright. This is Uranus, a giant world rotating not vertically as Earth does, but nearly horizontally, as though the entire planet has been laid down upon an invisible surface and left to tumble slowly through the cosmic dark. The axis of Uranus tilts at an angle of approximately 98 degrees from its orbital plane, which means that if you were standing on its equator at certain points in its long year, you would witness the sun rising not from the east, but from directly overhead at the horizon. The planet rolls along its path through space, like a great spinning ball that has been nudged onto its side, and this sideways orientation gives Uranus an almost dreamlike quality, a slowness that seems to whisper secrets about catastrophe and transformation written billions of years into the past. What caused this remarkable tilt remains one of the gentle, unsolved puzzles of planetary science, though astronomers have long held a thoughtful hypothesis that rests upon the imagination like a half-remembered tale. Early in the formation of our solar system, when the planets were still young and their orbits somewhat unstable, it is believed, and here we tread into the realm of careful speculation, that Uranus may have collided with a massive body, perhaps a protoplanet or a wandering object of considerable size, in a collision so ancient and so far away that no direct evidence remains except for the planet's present orientation. Such a collision would have been catastrophic in scale, a meeting between worlds that reshaped Uranus not in its composition, but in its fundamental orientation, tipping it over upon its axis like a great top struck a glancing blow. The impact would have released energy almost unimaginable in its intensity, sending shock waves through the still-forming layers of ice and gas that make up Uranus's substance. Yet in the cosmic timeline, this collision was ancient, happening somewhere between 4.5 billion years ago, and the planet has since settled into a quiet, almost meditative state, continuing its sideways rotation without urgency or resistance. What is remarkable is how stable this tilted rotation has remained across billions of years. The orientation has persisted, unchanged in any significant way, suggesting a kind of cosmic balance achieved through that ancient moment of violence. The tilt does not appear to be gradually correcting itself or shifting back toward a more conventional orientation. Instead, Uranus maintains its sideways spin with a kind of patient determination, completing one full rotation every 17 hours and 8 minutes, all while moving along its tilted axis through the void. This unique rotation has profound implications for the experience of seasons on Uranus. For approximately half of its 84-year journey around the Sun, a period so long that an entire human civilization might rise and fall, while Uranus completes merely half a lap, the north pole of Uranus faces directly toward the Sun, basking in continuous daylight. And then, slowly, inevitably, that eternal day passes into eternal night, and the South Pole rotates into the sunlight, while the North descends into darkness that lasts 21 years of Earth time. Imagine living through a season of perpetual noon, and then sleeping through a season of perpetual midnight, with the transition taking decades. The sideways nature of Uranus's rotation also means that the traditional concepts of how planetary atmospheres behave and how weather patterns form require gentle revision when applied to this tilted world. The sun's heat, rather than concentrating around an equator that receives the most direct rays, instead sweeps across the poles during different parts of the Uranian year, in patterns unlike anything found on the other giant planets. This creates a strange, slow-motion atmospheric system, one that scientists are still working to understand fully, a system shaped by geometry and time on scales that dwarf human understanding. There is something almost poetic about imagining the collision that created this tilt, a moment in deep time when two massive bodies met in the darkness, when Uranus was struck by another world and the course of its rotation was forever altered. Some scientists wonder whether this ancient impact may have also affected the internal structure of the planet, whether it might have disrupted the formation of the solid core that likely exists somewhere in Uranus's depths, buried beneath hundreds of miles of ice and atmosphere. Others have suggested that the collision might have also influenced the formation of Uranus's moon system, that perhaps moons were shattered and reformed in the aftermath of that distant catastrophe. Yet now, looking at Uranus as it rolls quietly through the solar system, one senses only tranquility. The violence of that ancient collision has faded into history, leaving behind only the gentle reminder of its occurrence. A tilted world, rotating slowly, maintaining its peculiar orientation as it has done for longer than human civilization has existed or could exist. And as Uranus continues its eternal journey around the Sun, completing its path at a pace so slow that we measure its year in decades, that sideways spin becomes not a sign of chaos, but a reminder of the deep time and vast forces that have shaped our solar system since before there were eyes to wonder at it. Imagine now the vast geometry of distance itself, the slow mathematics of space that separates Uranus from the heat and light that warms the inner worlds. The Sun, so brilliant and urgent from Mercury and Venus, grows dimmer with each orbital shell, each ring of planets drifting further into shadow and cold. When we measure the Earth's journey around the Sun, that familiar ellipse we call a year, we're measuring something intimate and swift. But Uranus, that distant, tilted wanderer, does not share our haste. Consider first the sheer remoteness. Uranus orbits at a distance of roughly 2,800,000,000 kilometers from the Sun. To hold that number in mind is nearly impossible. So instead, imagine this. If the Earth were a grain of sand resting 1 meter from a lamp, Uranus would be that same grain of sand resting 19 meters away. The Sun's light, traveling at 300,000 kilometers per second, takes only 8 minutes and 20 seconds to reach us here on Earth. The same light striking Uranus takes 2 hours and 40 minutes. 2 hours, nearly the length of a film. And that delay, that slow arrival of photons across the void, speaks to something profound about Uranus's solitude. What arrives even slower is the planet's completion of its orbit. While Earth circles the Sun in 365 days, Uranus takes 84 Earth years to make one full journey around its distant Sun. 84 years. The last time Uranus completed an orbit around our Sun, the Wright brothers had not yet flown. Horses still pulled most carriages. Queen Victoria still reigned. And in those 84 years, a human life can unfold almost completely. A child born when Uranus last reached the point it now revisits will have grown old and perhaps passed away before the planet returns to that same celestial location. But there is something even more extraordinary to contemplate, something that stretches the imagination in a different direction altogether. Because Uranus's 84-year orbit means that each season on Uranus, and Uranus does have seasons, though they are unlike anything we experience, lasts roughly 21 Earth years. 21 years of spring, 21 years of summer, 21 years of autumn, 21 years of winter. When a season begins on Uranus, the person born that day will have grown from a newborn into an adult before the same season ends. Picture the reality of this vast temporal scale. On Earth, we experience the wheel of seasons 4 times each year. The angle of sunlight shifts, the temperature rises and falls, the nights grow long, and the days grow long in their turn. We are accustomed to this rhythm. It is written into our biology, into the plants and animals that share our world, into our very sense of time itself. But imagine living on a world where one season lasts the span of 2 full decades. Imagine that the tilt of your planet has turned your hemisphere toward the sun, and for 21 years, that light increases slowly, steadily, degree by degree. The warmth, what little warmth reaches Uranus, accumulates across months and years. Snow that fell perhaps decades before begins to sublimate beneath a sun that never quite sets, that circles the horizon in this strange sideways world. The atmosphere, though still unfathomably cold, shifts subtly. Winds change their patterns. Clouds form and disperse over years. And then, after those 2 decades have passed, after a person has grown from adolescence to adulthood during a single season, it ends. The tilt continues its slow wheel. The sunlight begins to fade. Gradually, degree by degree, the temperature drops once again. The cycle that took 21 years to complete now reverses itself. Another 21 years of slow change in the opposite direction. An entire working life dedicated to the rhythm of a single seasonal transition. What would it feel like, psychologically, to live within such a timescale? How would a civilization mark the passage of time? Would an 84-year orbit seem like a grand cosmic year, a full return to origins? How would the memory of the last season, the last pass through that same orientation to the sun, haunt the minds of those who studied the records and the observations? There exists no being on Uranus that we know of, and perhaps there never will be. But the thought experiment stretches our sense of time itself, reminds us that duration is not absolute, but relative to the world upon which one dwells. The slow waltz of Uranus around the sun, then, is not merely a fact of orbital mechanics. It is a meditation on time itself, on the patience required to live in the outer solar system, on the way the cosmos measures itself in increments so vast that a human lifetime becomes almost negligible. Uranus completes its stately orbit while civilizations rise and fall on Earth, while empires are born and crumble, while technologies transform how we live and think, and the planet, in its tilted, solitary journey through the darkness, takes no notice. It simply continues its ancient path, patient as stone, cold as the vacuum that surrounds it. Beneath that serene blue-green face lies something far stranger than the solid surfaces we know from worlds closer to the sun. Uranus is not built of rock and iron the way Earth is, nor does it possess the crushing density of Jupiter's deep hydrogen heart. Instead, what we find is something altogether different, an ice giant, a world of layered ices and gases so peculiar that the very word ice takes on an almost dreamlike meaning when we venture this far from home. Picture, if you can, a descent through those pale clouds. You would fall first through an atmosphere of hydrogen and helium, the lightest elements, mixed with something that gives Uranus its color, methane, that simple molecule of carbon and hydrogen that floats beneath us in those distant clouds like a faint exhalation. The atmosphere is not thick or turbulent like Jupiter's storms. It feels, instead, like drifting through a kind of twilight haze, calm and almost yielding. And as you drop deeper, that haze begins to grow denser, warmer by degrees, though still impossibly cold by any earthly standard. Below the gaseous veil lies the true mystery. There is no sharp boundary where atmosphere ends and something else begins. Instead, there is a gradual, seamless transition into what astronomers call ices, a word that carries a different meaning here than it does on Earth. These are not frozen cubes in a glass. These are supercompressed layers of water, of ammonia, of methane itself, pressed down under gravity and pressure until they exist in states we rarely encounter. The molecules are still moving, still flowing in some sense, crushed into exotic crystal lattices or dense fluid states that we can only simulate in laboratories or imagine with the most precise calculations. Consider the strange poetry of this architecture. The ice layers are not motionless. They swirl, they circulate. Heat from below drives currents upward through these layers, and the rotation of the planet spins everything in a great, slow dance. The ammonia ice drifts past the water ice. The methane ice, buried deeper still, feels the pressure mount and mount until the very concept of what ice means begins to blur and change. Some of this methane, some scientists suspect, may actually exist in forms we do not yet fully understand, compressed so intensely that it might even take on properties we would call crystalline, gem-like. The word diamond has been whispered in connection with these depths, though we must hold that thought lightly, as speculation rather than certainty, for we have never touched these layers directly. What layers these must be. They do not sit in neat, distinct bands like paint on a canvas. They interpenetrate, they mix, they create gradients and currents. The water ice transitions gradually into something hotter, something denser, something more liquid-like as you go deeper. The ammonia does much the same, and all of this occurs in a kind of slow-motion ballet, influenced by the planet's rotation, by the faint heat rising from somewhere far below, by the pressure that increases with every kilometer of descent. The hydrogen and helium above, by comparison, feel almost ethereal. They are not really ice at all. They remain gaseous, a thin solution through which all the methane is mixed. Yet as you descend, that boundary becomes less distinct. At some point, and this is one of the great open questions about ice giants, the atmosphere simply becomes something else. Does it condense? Does it transform into a liquid state? Does it press so tightly against the layers below that it becomes indistinguishable from them? The honest answer is that we do not know with complete certainty. We have no probe that has ever traveled deep enough into Uranus's interior to tell us where these transitions truly occur. The whole structure seems to rotate as a unit, though we suspect there may be differential rotation in the depths, different layers spinning at different speeds, creating shear forces and internal stresses that we can only guess at. The planet's strange tilted axis means that these rotating layers are tilted too, swirling around a pole that was knocked nearly onto its side by some ancient catastrophe. And yet, there is something deeply calming about imagining this realm. These ices are not the hard, static ice of a frozen lake. They are dynamic, flowing, almost liquid-like in their behavior over long timescales. They exist in equilibrium, balanced between the cold that presses down from above and the heat that rises from below. Layer upon layer, they create a kind of stratification, a gentleness of structure that feels almost restful in its orderliness. This careful arrangement of materials, this slow, swirling dance of molecules under pressure and gravity. The entire world, all of it, is in motion, yet in balance. There is no solid surface to touch, no ground to stand upon. There is only this gradual, dreamlike transition from one state of matter to another, from gas to liquid to something in between, all the way down to depths we have never seen and may never directly observe. And so, as we drift closer to this distant world, something begins to shift in the quality of the light itself. The planet that William Herschel first glimpsed as a faint greenish smudge reveals itself now in deeper truth. Uranus wears a color that seems almost unreal in its serenity, a pale, luminous blue-green, like the memory of a twilight sky captured and held perfectly still. But this color, you might wonder, is not arbitrary. It is written into the very chemistry of the atmosphere itself, a silent conversation between light and the invisible gases that swirl around this distant world. The secret lies with methane. Methane, that same humble molecule that drifts from Earth's marshlands and animal breath, rises throughout Uranus's upper atmosphere in tremendous abundance. And methane, it turns out, has a peculiar preference. It possesses an almost selective appetite for certain colors of light. When sunlight, that white, complete spectrum of colors, falls upon Uranus from our distant sun, the methane molecules begin their quiet work. They absorb the reds and the oranges and the yellows. They drink in those warmer wavelengths as if they were thirsty for heat itself. What escapes, what bounces back toward the void, and eventually toward our eyes, is the blue and the green, the cooler half of the rainbow, the gentler hues. It is a process of subtraction rather than addition, not a surface painting or a deliberate coloring, but rather an absence of certain lights that makes the presence of others seem luminous. Think of a vast lake at twilight. You know that peculiar moment when the sun has descended below the horizon, and the sky has not yet surrendered to full darkness. The water below does not appear blue because someone dyed it. It appears blue because the warm colors of daylight have faded, and what remains visible is the light of the cooling sky reflected in its surface. The red and orange have withdrawn. Only the blue lingers, deepening, almost melancholic in its beauty. Uranus is suspended in a similar paradox. At such an incomprehensible distance from our sun, nearly 2 billion miles away, the sunlight that reaches it is already diminished to a faint gleam, and then the methane does its work, filtering away the remaining warmth, leaving only that deep, penetrating blue-green in its wake. The result is a world that appears serene in a way that our terrestrial intuition can barely grasp. Not the bold, rusty red of Mars, not the swirling whites and browns and oranges of Jupiter with its tempestuous storms, but instead a pale and steady aquamarine, calm and patient and almost timeless. It is worth pausing here to consider what this color truly means. When we look at Uranus through our telescopes and our instruments, we are not seeing a solid surface. There is no rocky shore, no firm boundary where the atmosphere ends and a body begins. What we observe instead is the uppermost layer of a vast, deep atmosphere, and the color we perceive is the light that has traveled through that medium, scattered and filtered by the methane it contains. In a sense, we are looking not at the planet itself, but at the light passing through it, and the methane, like a tinted lens held before distant eyes, transforms that light into something that speaks of distance, of cold, of profound solitude. The pale blue-green of Uranus has sometimes been compared to sea foam or frosted glass, to the color of water viewed from certain angles in certain light. But perhaps the most apt comparison is with that peculiar shade of blue-green that appears in the sky itself during the hour when day is releasing its grip on night, that threshold color, that moment when the world holds its breath. This is the tint that Uranus wears perpetually, a planet forever suspended in a kind of cosmic twilight, reflecting back at us a color that seems to carry with it some echo of stillness, of waiting, of the deep and patient rhythms of a world that turns far from our sun's direct gaze. The methane in Uranus's atmosphere exists in concentrations that far exceed what we find in Earth's skies or Jupiter's turbulent clouds. This abundance ensures that the filtering effect is pronounced, almost absolute. Very little of the warmer light finds its way back to us unchanged. The planet seems to have deliberately chosen this muted palette, though of course no choice was made at all. It is simply the outcome of chemistry and physics, of light and matter conversing according to laws that are utterly indifferent to our aesthetic preferences. Yet still, the result moves us. The color invites a kind of peace. And here is something particularly soothing to consider. This color is constant, whereas Jupiter's storms churn and shift, creating great swirls of different hues that race across its surface. Uranus presents an almost unchanging visage. No dramatic color shifts. No violent atmospheric disturbances painting the world in new shades from season to season. The pale blue-green endures, steady and unmoving in appearance, as if the planet itself has achieved some state of atmospheric equilibrium that our more volatile world can scarcely imagine. The methane that creates this color is not a barrier or a veil. It is not hiding something more vivid beneath. It is simply the honest face of a world so distant and so cold that its very atmosphere has a kind of quieting effect on all that we perceive. The light that reaches us from Uranus is the light that the methane has chosen, in its patient molecular way, to release. And in accepting that light, in letting it settle into our understanding, we participate in a very gentle truth. Some of the most beautiful things in the universe are beautiful precisely because they are subtle, because they require attention, because they speak in the soft language of a distant twilight, rather than the bold shout of a noonday sun. And as we drift closer still, we encounter a cold so profound that it seems to reshape what we understand about temperature itself. The atmosphere of Uranus is, in many ways, among the most frigid environments in our entire solar system, a place where the thermometer plummets to readings that feel almost incomprehensible when held up against the warm terrestrial world we know. The uppermost clouds of Uranus, those soft layers of hydrogen and helium that paint its subtle aquamarine face, exist at temperatures around 57 Kelvin, which translates to roughly -216 degrees Celsius. To truly grasp what this means, consider that the coldest natural temperature ever recorded on Earth's surface, in the depths of Antarctica, barely dips below -90 degrees, and yet Uranus maintains its frozen stillness at temperatures nearly 3 times colder than that, continuously, eternally, across its entire visible atmosphere. This extreme cold is in many ways what we would expect from a world so distant from the sun's warmth. Uranus orbits at roughly 20 billion kilometers from our star, a journey that takes 84 Earth years to complete. And at such a vast remove, the sunlight that reaches it is dim and diffuse, offering only a fraction of the solar energy that nurtures the inner planets. Yet here is where something truly curious emerges, something that has puzzled planetary scientists for decades and continues to invite quiet speculation even now. Unlike Jupiter and Saturn, those other two gas giants that shine in the night sky with their own internal heat left over from their formation billions of years ago, energy still radiating outward from their cores, Uranus appears strangely reluctant to glow from within. Its interior heat signature is nearly imperceptible, which raises an intriguing question: where has that primordial warmth gone? The other ice giants and gas giants in our solar system behave rather differently in this regard. Jupiter, for instance, radiates almost twice as much energy as it receives from the Sun, a phenomenon that scientists attribute to the gradual compression of hydrogen within its massive interior, a slow gravitational squeeze that generates heat over the eons. Saturn radiates roughly double the energy it absorbs as well. Even Neptune, positioned even farther from the Sun than Uranus, appears to maintain a more robust internal heat output than its slightly closer sibling. Yet Uranus, by contrast, seems to emit almost no detectable internal warmth at all, a puzzle that invites contemplation. There are several gentle hypotheses that scientists have proposed to explain this mystery. Some researchers wonder whether a catastrophic collision, the very impact that may have tilted Uranus so radically onto its side, might also have dispersed much of its primordial heat into the vast cold of space. A collision of such magnitude would have been violent enough to jostle the planet's internal structure, perhaps allowing heat to escape in ways that prevented the usual compression-driven warming that keeps other giants luminous from within. It is a sobering thought, really, the idea that violence in the deep past could leave such a lasting mark, cooling an entire world. Others have suggested that Uranus might simply have formed differently than its neighboring giants, perhaps condensing more slowly or from a different composition of materials, in ways that left it with less internal thermal energy to begin with. The interior structure of these distant worlds remains largely theoretical, pieced together from distant observations, gravitational measurements, and mathematical models that are, at best, educated guesses about what lies beneath those cloud layers. There is something rather peaceful about this admission of uncertainty, the recognition that even with all our modern instruments and scientific sophistication, these far distant worlds can still hold on to their secrets. What makes Uranus's coldness all the more striking is the contrast it presents to the very gentle, almost languid character of the planet itself. Because it rotates so slowly, with its sideways axis taking 42 hours or so to complete one rotation, the distinction between day and night across its surface becomes blurred in ways that are difficult to fathom. The sun rises and sets with such lethargy across its frozen atmosphere that the concept of day almost loses meaning. And yet, day after day, year after year, this deep freeze persists, methane ice crystallizing in the upper atmosphere, hydrogen and helium swirling in winds that move, despite the eternal cold, at speeds reaching 600 kilometers per hour. The wind itself becomes a kind of warmth by contrast, at least in the sense that it represents motion and energy, a stirring of the atmosphere that prevents total stasis. The cold of Uranus is not uniform either. While the upper atmosphere hovers at that extreme 57 Kelvin, the temperature profile changes as one descends deeper into the planet, warming gradually as pressure increases and the layers of ice beneath become less transparent to our instruments. This temperature gradient, this slow warming with depth, represents energy in transition, heat flowing from wherever it originates deep within toward the frigid surface above. But the rate of that warming is gentler than what we observe on other planets. Another whisper of mystery, another soft question mark hanging in the void. And perhaps there is something peculiarly beautiful about a world so cold, so removed from the life-giving warmth of the sun, existing in such profound tranquility at the edge of our solar system. The extreme cold renders Uranus almost unchanging on human timescales, a realm of stasis and stillness where weather patterns persist for decades, where the very composition of its atmosphere seems locked in a kind of suspended animation. The methane that gives it its blue-green color absorbs the red wavelengths of light, leaving only the cool end of the spectrum to reflect back toward us, and now we know that this cool palette extends not just to its appearance, but to the very essence of its nature, a world wrapped in depths of cold that seem almost beyond the reach of understanding from our warm vantage point here in the inner solar system. And so as we drift deeper still into the mysteries of this tilted world, we find ourselves drawn to something equally unexpected, equally hidden, something that took centuries to reveal itself, waiting patiently in the dark like a secret whispered in the silence of space. For most of history, Uranus seemed to observers a lonely world, a pale blue-green sphere, distant and still, orbiting with its companions through the vast cold reaches beyond Saturn's realm. No rings, or so it seemed. But the universe has a way of concealing its subtlest treasures, and on a particular night in March of 1977, astronomers pointing their telescopes toward a distant star had no idea they were about to witness something profound. A stellar occultation, they called it, a moment when Uranus would pass directly in front of a faint star in the background, momentarily blocking its light. It was a routine observation, a calculated event, a chance to gather data about Uranus's atmosphere as the planet's edge swept across that distant stellar beacon. But something unexpected happened, something that made them pause. Before the star vanished behind Uranus itself, its light flickered, it dimmed, and then, as the planet passed, it dimmed again on the other side, a ghostly pattern of shadows dancing before and after the planet's main shadow. The observers checked their instruments. They looked at their notes. What they had glimpsed, in those precious moments, were rings, faint rings, dark rings, rings so thin and so subtle that they had evaded detection for all the decades since Uranus's discovery. Rings that seemed almost reluctant to announce themselves, as if they preferred their solitude. Think of it for a moment. Saturn's rings are magnificent, brilliant bands of ice and rock that catch the sun's light and shimmer across space like nature's most elaborate crown. They are hard to miss, impossible to ignore. But Uranus's rings, they are something altogether different. They are, in a word, quiet, almost shy. Composed largely of dark material, possibly carbonaceous rock and dust, they absorb rather than reflect the sun's light. They are thin, in many cases barely a few hundred meters across, fragile-looking threads arranged in concentric circles around the planet's strange rolling axis. That first detection in 1977 was followed, in subsequent months and years, by the discovery of more rings as astronomers trained their instruments on Uranus during similar occultations. The rings emerged from the darkness, not all at once, but gradually, like words appearing one by one on a page. Some were named for scientists who contributed to planetary discovery. Others bore the designations of Greek letters and Roman numerals, a catalogue of the delicate and the dim. Today we know of at least 13 distinct ring systems around Uranus, each one thinner, each one fainter, each one a marvel of cosmic subtlety. What makes these rings so particularly fascinating, so gently mysterious, is that they seem to hint at a restless history. Ring systems, astronomers theorize, do not last forever. They are mortal things in cosmic terms. The particles that compose them gradually spiral inward toward the planet, drawn by gravitational forces, lost to the great blue-green depths below. Yet Uranus's rings persist. How do they maintain themselves across such vast stretches of time? What fed them? What sustains them? One answer lies in the smaller moons that orbit nearby, shepherding rings, nudging them, preventing them from spreading too wide or collapsing inward too quickly. These moonlets, these tiny shepherds of ice and stone, guide the ring particles as if with an invisible hand, a cosmic caretaker's gentle touch. It is a reminder that even in the deepest dark of the solar system, in the cold reaches where Uranus silently spins, there are relationships, connections, systems of mutual influence that keep things in their delicate balance. The rings themselves, when light does manage to scatter off them, shine with a peculiar darkness. When Voyager 2 passed through the Uranian system and turned its instruments toward these gossamer structures, the images revealed something almost dreamlike. Rings so faint they seemed barely real, threads of shadow and reflection barely distinguishable from the background void. They circle that tilted world in perfect stillness, silent witnesses to the planet's strange rotation, participants in a quiet cosmic dance that has been unfolding since before our Earth was born. It seems almost fitting, does it not, that a world so unusual in its orientation, so distinctive in its tilt, should be adorned with rings that are themselves out of step with convention. Saturn's rings blaze and shine, proclaiming themselves to every corner of the solar system. But Uranus's rings whisper, they hint, they require patience to perceive, dedication to understand. They are rings for those willing to look closely, to wait, to to sit with the unknown and allow it to gradually reveal its shape in the darkness. Orbiting this distant tilted world, in the cold and stillness beyond the asteroid belt, there exist not planets, but kingdoms of ice and rock, bearing names drawn from the greatest poets of the English language. When astronomers first began to catalogue the companions circling Uranus, they made an unusual and luminous choice. Rather than naming these moons after gods and mythological figures in the traditional way, they turned to the literary works of William Shakespeare and Alexander Pope, those masters who had captured the deepest longings and mysteries of the human heart. And so, in the cold outer darkness, there dwell worlds named Titania and Oberon, Miranda and Ariel, Puck and Prospero. Each name carries with it the echoes of drama and enchantment, of magic and transformation written long ago by candlelight in theatres warmed by human breath. Titania orbits in silence, a moon of some 1,600 kilometers across, moving through the darkness as the fairy queen of Shakespeare's Midsummer Night's Dream once moved through an Athenian forest. Can you imagine the curiosity of those 19th century astronomers, sitting in their observatories with telescopes pressed to their eyes, discovering new worlds and deciding to honor them not with the names of ancient gods, but with the characters who had moved audiences to tears and laughter? It speaks to something profound in human nature, the desire to carry our stories, our art, our deepest imaginings outward into the cosmos itself. Oberon dances alongside Titania in its own orbit, a massive companion moon some 1,500 kilometers in diameter, named after the fairy king, the male counterpart to Titania in that same midsummer dream. The two move together through the void, in an almost choreographed rhythm, their gravitational embrace keeping them in their ancient paths around their blue-green parent. Imagine standing on the icy surface of one and looking up to see the other hanging in a black sky, itself a world orbiting the same system. The poetry of it settles into stillness. Miranda holds a particular fascination among the moons of Uranus, a smaller world at perhaps 470 kilometers across, yet her name carries the weight of wonder. She is the daughter in The Tempest, the character who speaks those lines that seem almost a question addressed to the universe itself. Oh, wonder! How many goodly creatures are there here? Miranda, young and innocent, arriving on a magical island, seeing wonders for the first time. And her namesake in the outer solar system is no less wondrous, a world of jumbled terrain and towering cliffs that seem to speak of ancient cataclysms and reassemblies, of a moon that has known destruction and reformation. Ariel, too, flows from that same Shakespearean spring, the spirit of air and magic in The Tempest, a being of remarkable freedom and grace. The moon Ariel is smaller still, about 1,160 kilometers across, orbiting between Miranda and the more distant larger moons, a world bathed in eternal twilight and the faint glow of reflected sunlight from the distant sun. What would it mean to name a world after a spirit of pure air? Perhaps there is something in the imagination of those early astronomers that sensed the ephemeral nature of these distant icy spheres, their transience in cosmic time, their existence in realms of cold and silence almost dreamlike in their remoteness. Puck carries forward the thread of Shakespearean whimsy, a smaller moon orbiting among the others, named after that mischievous sprite who wandered through the enchanted forest seeking to right wrongs and create confusion in equal measure. The moon Puck, some 180 kilometers across, is itself a kind of cosmic jester, small and distant and difficult to observe from our vantage point, yet possessing its own reality and significance in the grand ballet of planetary mechanics. And then there are moons named from Pope's Rape of the Lock, ethereal female characters from that mock heroic poem, Umbriel, Belinda, and others, adding another layer of poetic resonance to this pantheon of icy worlds. These names whisper through the astronomy textbooks and scientific papers, reminders that the universe we observe is filtered through the lens of human culture, human imagination, human longing to make sense of the cosmos through the stories we tell ourselves. The naming of worlds after literary characters reveals something gentle and deeply human. In a universe of such vast indifference, where stellar radiation and cosmic radiation and the vast empty spaces between stars operate according to purely mathematical laws, we choose to impose upon distant objects the names of our greatest characters and dreams. We look outward to the darkness and we say, "These worlds shall bear the names of Titania and Oberon, because their stories matter to us, because the wonder they express in us is the same wonder we wish to find among the stars." There is something calming in this thought as you drift through these ideas. These moons move in orbits precisely calculated and wholly predictable, their masses and distances established by observations and equations. Yet their names carry the incalculable weight of human creativity, the unmeasurable depths of artistic vision. They are, in a sense, both cold mathematical objects and repositories of human meaning, worlds of ice and darkness that nonetheless reflect back to us our greatest imaginings. The major moons of Uranus number more than 24 now, as observational technology has improved and smaller bodies have been detected in the shadows around the primary world. But it is those first few, those luminous names drawn from the greatest works of English literature, that carry the poetic weight of discovery and the gentle reminder that as we venture outward in understanding the cosmos, we need not abandon the stories that make us human. We can carry them with us, inscribe them upon worlds of ice, let them echo across the solar system as reminders that science and art, mathematics and imagination are not opposed to one another, but are instead reflections of the same deep human impulse to understand and find meaning in existence. Among all these moons that drift in their ancient Shakespearean reverie, there exists one world that seems almost impossibly fractured, almost like a shattered marble that somehow pulled itself back together and continued spinning into the void. That world is Miranda, and its surface tells a story so strange, so deeply bewildering, that astronomers still turn the puzzle over in their minds, searching for the narrative written in its stone. When Voyager 2 passed through the Uranian system in 1986, it transmitted back images of Miranda that seemed almost to defy comprehension. Here was a moon, barely larger than a city, bearing a geography that appeared almost deliberately chaotic, as if some cosmic child had broken a world into pieces and then haphazardly reassembled it, leaving the seams and fractures visible as monuments to its violent past. The images showed cliffs of staggering height rising from the frozen landscape, some of them reaching nearly 10 miles into Miranda's thin sky. 10 miles, on a moon so small that you could walk around its equator in a handful of hours. These scarps loomed like cathedral walls, casting long shadows across terrain that seemed to shift and change as if caught in a perpetual geological argument with itself. The surface itself appears as a kind of patchwork, a quilt stitched together from different pieces, each one tilted at its own distinct angle. Some regions are smooth and relatively undisturbed, while others are carved into deep trenches and ridges that create a texture so intricate, so elaborately fractured, that it almost seems deliberate, as though someone were testing the limits of what geological possibility could produce. The entire moon looks wounded, transformed, marked by something that happened long ago and left scars that have never quite healed. What makes Miranda's appearance so haunting, so deeply intriguing to those who study these distant worlds, is the question that hovers constantly over its fractured face. How did this small moon end up looking the way it does? The predominant theory, one that grows more persuasive the more carefully scientists examine the data, suggests that Miranda experienced something catastrophic, something that should have destroyed it utterly. The speculation, offered always with appropriate scientific caution, is that this moon may have been shattered, completely shattered, broken apart by a collision with something else moving through the darkness, some ancient impactor that struck with devastating force. And then, in what would seem almost impossibly fortunate, gravity did something remarkable. The fragments that had been torn loose, scattered into space, somehow found their way back to one another. Gravity, that patient and relentless force, drew the pieces together again, and they coalesced, reaccreted, coming back into something resembling a single body once more. But when those pieces came back together, they did not reassemble with the order and symmetry of their original configuration. Instead, they joined together at odd angles, in a jumbled embrace that preserved the evidence of their violent separation. The cliffs you see, those towering scarps that dominate Miranda's landscape, may well be the edges where different pieces of the original moon met as they reformed. The patchwork of different geological regions, each one tilted differently, each one bearing its own character, may represent distinct fragments that have preserved their individual orientations even as they came back into gravitational contact. In this view, Miranda becomes a kind of astronomical palimpsest, a world whose surface is a direct record of its own shattering and reassembly. How long ago did this catastrophe occur? The timeline remains uncertain, dwelling in that comfortable realm of scientific mystery. It may have happened billions of years ago, so distant in the past that the details have grown fuzzy even in the geological record. It may have happened when the Uranian system was young, when collisions between objects were more frequent, when the dance of worlds was still chaotic and unpredictable. The energy released by such an impact, the force required to break apart an entire moon, staggers the imagination. And yet here it sits, apparently stable now, having settled into its fractured state and somehow maintained that configuration across eons of time. There is something almost meditative about contemplating Miranda in this way. A world that was broken, that fell apart entirely, that was scattered into fragments and darkness, somehow found itself again. The pieces gathered, drawn by forces they could not resist, and they came back together. What remains is not pristine, not perfect, not symmetrical, but it endures. The evidence of the violence remains written across the surface, never to be erased, and perhaps that is the most beautiful thing about it. Miranda does not hide its history. It wears its fractured nature openly, and in that broken geometry, there exists a kind of strange peace, a quiet acceptance of what happened and what came after. In the cold expanse of the outer solar system, there exists a single moment frozen in the memory of planetary science, a brief, hushed encounter that would stand as humanity's only close visit to this tilted world. The year was 1986, and a spacecraft called Voyager 2, having already swept past Jupiter and Saturn in earlier years, was approaching the blue-green sphere of Uranus, with instruments humming softly in the vast darkness. For decades before and after, no human probe would venture so close to this distant ice giant, making that encounter feel, in retrospect, almost like a fleeting whisper spoken in the night. The spacecraft had been traveling for 9 years since its launch in 1977, moving through the solar system on a trajectory that, by fortune and careful engineering, would carry it to within just 81,000 kilometers of Uranus's cloud tops. That may seem like an enormous distance from the perspective of Earth, yet in the context of the outer solar system, where worlds drift in isolation across millions of kilometers, it was an intimate approach, close enough to reveal details no telescope on Earth could ever perceive. The encounter itself would last only a few hours, a brief brushing past the planet's upper atmosphere, as Voyager 2 continued its eternal journey toward the outer darkness beyond. Picture, if you will, the silence of that approach. The spacecraft moved through a region of space so remote that radio signals, traveling at the speed of light, took nearly 2.5 hours to make the round trip from Earth to the craft and back again. Any conversation between mission controllers and the probe existed in a profound delay, a one-way dialogue stretched across cosmic distance. Scientists on Earth had sent instructions months before, programming the spacecraft to gather specific measurements and point its instruments at precise moments, trusting that the machinery would function perfectly in an environment so cold and strange that it seemed almost hostile to human technology. As Voyager 2 swept past, its cameras captured the planet's muted, almost serene features. The atmospheric clouds that drifted across Uranus appeared in those images as subtle striations of pale color, quieter and less turbulent than the dramatic storm systems visible on Jupiter or Saturn. There was something almost peaceful about the scene, as if the distant ice giant existed in a state of cosmic repose, undisturbed by the violence that might be expected from such a massive world. The spacecraft's sensors measured the planet's temperature, its atmospheric composition, the strength of its magnetic field, collecting data that would take years to fully analyze and understand. One of the most significant discoveries came almost by accident. As Voyager 2 passed behind Uranus from Earth's perspective, the spacecraft's radio signal was absorbed and refracted by the planet's atmosphere in a carefully choreographed way. Scientists on Earth, listening to the distorted signal, could extract information about the density and temperature of the atmosphere at different altitudes, effectively using Uranus itself as a lens through which to measure its own properties. It was a technique called radio occultation, and it revealed that Uranus's atmosphere was even colder in certain regions than models had predicted. The spacecraft also discovered several new rings around the planet, faint and dark structures that had eluded detection from Earth. These rings seemed to shimmer with a subtle, elusive quality, difficult to photograph yet undeniably present in the data. Some of Uranus's known moons appeared in the images as well, small, distant spheres that reflected barely perceptible amounts of sunlight, orbiting in the quiet darkness far from the sun's warmth. Voyager 2's cameras captured details of their surfaces, revealing landscapes that spoke of ancient histories written in impact craters and strange geological features. But the encounter was brief. After those few hours of intense observation, the spacecraft's trajectory carried it away from Uranus, beginning its long passage toward Neptune, which lay waiting billions of kilometers ahead. Within days, Uranus had receded to a pale dot in the spacecraft's rear-facing cameras, soon to disappear from view entirely. The brief moment of close contact had ended, and the planet returned to its isolation, a world visited once and then left alone for decades stretching into the future. There is something deeply affecting about contemplating this solitary encounter. For all of human history before 1986, Uranus existed as a faint, featureless dot through telescopes, a mystery wrapped in distance. Then, in a single window of time that lasted mere hours, a robotic ambassador arrived and revealed its secrets, gathering information that would occupy scientists for years. And then it was gone, continuing its slow passage outward, leaving no promise of soon return. No spacecraft has followed in Voyager 2's path. No orbiter has taken up residence around the distant ice giant. No lander has ever touched its clouded surface. The data that Voyager 2 gathered has proven to be both revelatory and tantalizing. It answered many questions about Uranus's internal structure, its magnetic field, the nature of its rings and moons. Yet in answering them, it raised new questions, mysteries that would require closer investigation to solve. Scientists could not have known, in those hours during 1986, that this single flyby would represent humanity's only close encounter with Uranus for what may be many more decades. The spacecraft was programmed to continue onward, toward Neptune, toward the edge of the solar system, following a path from which there was no turning back. And so Voyager 2 slipped away from Uranus into the void, carrying with it the memory of that brief meeting, the record of details observed and data collected. The spacecraft would eventually pass Neptune as well, and then it would drift beyond the orbits of all known planets, moving through the Kuiper Belt and beyond, becoming perhaps the most distant ambassador humanity has ever sent into the cosmos. Yet that moment with Uranus remained in its memory banks, encoded in ones and zeros, a quiet chronicle of an encounter that occurred in the vast silence of deep space, witnessed only by instruments and the scientists far below on Earth, listening to the faint radio signals that told the story of that distant, tilted world. And if we linger now in the upper reaches of Uranus's atmosphere, drifting through those wind-swept clouds of methane and hydrogen where the pressure builds and the cold deepens, we might ask ourselves a quieter question still. What happens to light and magnetism when they meet in the presence of a world so utterly tilted, so askew in its very essence? For Uranus harbors within itself a magnetic field unlike anything else we know, a compass needle spun at an angle so severe, so strange, that it paints the polar regions of this distant ice giant with auroras of a peculiar and lopsided kind. The magnetic field itself, you see, does not align neatly with Uranus's rotation. It never has, and we are only beginning to understand why. Where on Earth our magnetic poles drift slowly through the millennia, always recognizable as poles, on Uranus, the magnetic axis tilts a full 59 degrees away from the rotation axis itself. Imagine a compass so twisted, so fundamentally at odds with the spinning motion beneath it, that the very definition of north becomes uncertain. And more curious still, the field's center does not sit at the planet's geometric center, but is offset, displaced by roughly 1/3 of the planet's radius. This is not symmetry. This is not the elegant tidiness we might expect from a massive sphere of swirling hydrogen and ice. What this means, in the gentlest terms, is that the auroras on Uranus dance in patterns that seem almost unmoored from their world. On Earth, we are accustomed to thinking of auroras as circular crowns around the magnetic poles, the northern lights framing the Arctic sky, the southern lights dancing above Antarctica's glaciers. But Uranus inverts that expectation. Because the magnetic field is so tilted, so displaced, the auroras on this distant world do not form neat rings. Instead, they drift, they pulse. They describe lopsided, asymmetrical patterns across the upper atmosphere, as though the planet's magnetosphere has been given a gentle push, causing it to wobble and sway. Picture yourself suspended in thought above one of Uranus's poles, a pole that shifts its position subtly as the planet rotates, because the magnetic axis wanders so far from the spin axis. The charged particles from the solar wind strike the upper atmosphere, drawn in by the twisted magnetic field, and where they collide with molecules of hydrogen and methane, they produce light. But this light is not concentrated, not focused. It drifts, it spreads, it moves in slow, grinding arcs across the poles, sometimes far from where a conventional polar aurora would appear. These are lanterns hung by an invisible, lopsided geometry, moving with a strange, unhurried grace that we have only begun to comprehend through our instruments and our patient observations. The offset of the magnetic field, this displacement from the center, creates something yet more peculiar still. As Uranus rotates, its magnetosphere rotates with it, but not in the way we might expect. The offset means that different longitudes experience different magnetic field strengths. In one hemisphere, the field intensifies. In the opposite hemisphere, it weakens. The auroral oval itself, that luminous crown where the magic happens, tumbles across the poles as the planet spins, tracing a lopsided path that would dazzle any observer patient enough to watch it for hours, or days, or the slow progression of Uranian seasons. We do not yet fully understand why Uranus's magnetic field chose this strange configuration. We have theories, of course, soft speculations whispered between planetary scientists in quiet moments. Some suggest that the offset and tilt may be temporary, a lingering echo of some past disturbance in the planet's interior, a magnetic configuration in slow transition towards something more stable. Others wonder if the field itself is generated in an unusual way, perhaps in a thin layer of conductive fluid somewhere in Uranus's deep interior, far from the geometric center, far from the rotation axis. Perhaps the chaotic, tilted collision that set Uranus on its side billions of years ago also left its imprint on the magnetic machinery deep within, a scar that has never fully healed. What we do know is that this strange magnetic geometry creates an environment that is, in its own way, profoundly beautiful. The auroras of Uranus, though we cannot see them directly in human terms, exist in wavelengths our instruments can perceive. They shimmer with ultraviolet light, with hydrogen alpha emissions, with the subtle glow of excited atmospheric molecules. They are auroras that move in slow time, drifting across weeks and months, painting patterns that follow no familiar earthly logic. If one could somehow project these auroras into our own visual spectrum, if we could witness them as we witness the northern lights, we would behold something utterly alien, a cascade of light moving in slow, asymmetric waltzes across a tilted pole, guided by a compass that spins and wobbles, offset and askew. There is a kind of meditation in this thought. A magnetic field is, in the deepest sense, an invisible river of force, flowing from the interior of a world outward into space. Normally, we imagine such rivers as orderly things, with sources and destinations, with poles that stand sentinel and still. But on Uranus, the river itself is twisted, the current spirals. The compass points somewhere between true north and true east, and that somewhere shifts with every rotation of the planet beneath it. The aurora, that oldest of space weather phenomena, becomes something stranger here. It becomes a slow-motion storm of light that drifts and dances to the tune of a magnetic geometry that breaks every familiar rule. And perhaps in contemplating this beautiful strangeness, this lopsided geometry of magnetism and light at the edge of the solar system, we begin to understand something deeper about the cosmos itself. Worlds need not conform to our expectations. Order can be hidden beneath apparent chaos. Symmetry can be broken. Asymmetry can birth its own kind of beauty. And far from home, in the cold and dark, auroras dance their slow and wandering dances, guided by compasses that point in directions we are only now beginning to recognize and name. And there remains something almost poetic about the deepest layers of Uranus, where the pressures and temperatures climb toward conditions we have only theorized about, never truly witnessed. As we sink deeper through that swirling methane-tinged atmosphere, past the visible clouds and the winds that race in their perpetual patterns, we enter realms that exist almost entirely in the language of physics and careful supposition. Deep within Uranus's interior, beneath the layers of water ice and ammonia that give it the name ice giant, there exists a mantle of compressed material under pressures so immense that the familiar states of matter begin to behave in strange and unfamiliar ways. And it is here, in this realm of crushing force and extraordinary heat, that some of the most captivating mysteries of Uranus reside. Scientists have long wondered, and here we must speak carefully, for we are moving into terrain where certainty gives way to thoughtful calculation, whether the pressures deep inside this distant world might be sufficient to transform carbon compounds into something far more exotic. Imagine, if you will, the carbon atoms that exist within Uranus's interior, pressed down and heated by the weight of countless kilometers of material above them. Under such circumstances, under pressures that dwarf anything we might create in our laboratories on Earth, carbon can take on a crystalline structure that appears, in theory, precisely as a diamond would appear. And so there is a possibility, spoken softly, because the evidence remains indirect and woven together from extrapolation, that Uranus harbors within itself rain made not of water, but of diamonds, a slow, eternal cascade of gemstones drifting downward through the heat and pressure of that mantle, settling deeper still, accumulating over the eons into layers of condensed riches that no human eye has ever glimpsed. It is a beautiful thought, is it not? And yet we must hold it lightly. The conditions that might give rise to such diamond rain are based on our understanding of how carbon behaves under extreme pressure, derived from laboratory experiments and the physics we have learned through studying other worlds. But Uranus keeps its secrets close. We have visited it only once, with Voyager 2, and that brief encounter, remarkable as it was, could not take us into the interior, could not measure the precise conditions at the boundary between the icy mantle and the rocky or metallic core that may or may not exist at the very center. Beyond the possibility of diamond rain, there is deeper speculation still about the nature of those compressed ices in Uranus's interior. Water ice, ammonia ice, methane ice. These are not stable in their ordinary forms when subjected to the forces present deep within this ice giant. Instead, they may undergo phase transitions into exotic states of matter known as superionic ices, where the molecular structure reorganizes into configurations that have no natural counterpart on Earth's surface. In superionic water ice, it has been theorized, the hydrogen atoms move freely through a lattice of oxygen, creating something that is neither quite ice nor quite liquid, but rather a strange third state, existing only under these singular circumstances. And if such exotic ices exist within Uranus, they would be composing vast layers of this alien world, making it perhaps even more unusual than we had imagined. These thoughts rest in a kind of productive uncertainty. The physics suggests they could be real. The models whisper that such phenomena might occur. But confirmation awaits a mission that has not yet been launched, instruments that have not yet been built, a future moment when humanity might choose to send a probe that could descend into Uranus's atmosphere, taking measurements all the way down into regions we cannot now observe directly. Until that day arrives, the diamond rain and the superionic ices remain among Uranus's quietest mysteries, whispered about in astronomical literature, incorporated into computer simulations, held in the imagination as possibilities rather than certainties. And perhaps there is something restful in this unknowing, in the recognition that even our most distant neighbor in the region of ice giants retains depths we have not fathomed, phenomena we have not directly confirmed. The universe, in all its vastness, is not diminished by our incomplete understanding. Rather, it reminds us that mystery itself can be a source of wonder, that the greatest gift of science is often not final answers, but rather the opening of new and more beautiful questions, layered upon one another like those theoretical deposits of diamond deep within that blue-green world, waiting, perhaps forever, to be confirmed. Yet here stands Uranus, vast and luminous in the distant dark, and here too stands a curious quietness in our knowledge of it. For all that we have learned through telescopes and through that single fleeting moment when Voyager 2 swept past in 1986, Uranus remains perhaps the most gently forgotten world in our solar system. Why is it that this pale blue-green sphere, so strange and tilted and layered, continues to drift in such profound obscurity at the edge of human exploration? The answer rests partly in the brutal geometry of distance itself. To send a spacecraft to Uranus requires not merely fuel and ingenuity, but a patience that stretches across years and decades of silence. A journey from Earth to the ice giant demands somewhere between 10 and 20 years of voyage time, depending on the trajectory chosen, depending on the fickle alignments of planets that open or close the windows of opportunity. A spacecraft bound for Uranus launches not knowing if its instruments will survive the radiation belts of Jupiter's neighborhood, if its solar panels, so far from the distant sun, will gather sufficient light to power its systems, if the vast cold will make its mechanics brittle and slow. And then, After all that time in transit, after crossing billions of kilometers through the vacuum, the encounter itself is fleeting. A few hours, perhaps a day or two, to gather images and measurements and data before the spacecraft must drift onward into the outer void, leaving behind all the questions that remain unanswered. This is partly why Uranus has receded into quiet neglect. Unlike Mars, which lies close enough to send rovers that can work for years, unlike Jupiter and Saturn, which have hosted a succession of orbital missions and atmospheric probes, Uranus has received the briefest of visits. There is something almost melancholy about this asymmetry. The planet hangs there in the dark, spinning on its side through the void, and yet we have only glimpses. We have photographs and spectral data and a handful of measurements of its magnetic field, and then silence again. For decades now, since 1986, we have watched Uranus from afar but never touched it, never truly known it as we might know it. The practical difficulties compound this distance into a kind of exploratory hesitation. A mission to Uranus must carry instruments designed to withstand temperatures that would make even the hardiest materials brittle and strange. The cold alone, imagine it if you can, a cold so profound that ammonia freezes solid, that water becomes like stone. This cold works slowly against every delicate circuit and sensor. The spacecraft must carry its own power source, often nuclear, because the sun is so faint at that distance that traditional solar arrays provide barely a whisper of electricity. And then there is the problem of trajectory itself. The planets do not simply sit in a line, they move and wheel in their orbits, and the paths that connect them shift with the passage of years. To reach Uranus efficiently requires launching during narrow windows that open only rarely, perhaps once every 13 years or so, when the relative positions of Earth and Uranus align in ways that permit a fuel-efficient route. For all these reasons, and perhaps for simpler ones too, the pull of human attention toward the warmer, closer, more immediately mysterious worlds, Uranus has drifted in a kind of gentle obscurity, even as our understanding of the rest of the solar system has deepened and multiplied. Yet this obscurity, this gap in our knowledge, has also become a kind of invitation. In recent years, whispers of renewed interest have begun to drift through the quiet corridors of space agencies and research institutions. There is talk, soft but growing steadier, of a proposed orbiter mission to Uranus, sometime in the 2030s or 2040s. Picture it, if you will, a spacecraft carrying advanced imaging instruments, spectrometers sensitive enough to read the faint chemical signatures of the atmosphere, magnetometers to unravel the strange tilted geometry of that lopsided magnetic field. Such a mission would not be a brief encounter as Voyager 2 was, but rather a sustained presence, a spacecraft settling into an orbit around the ice giant, observing and measuring for years. What might such a mission reveal? This is where speculation begins to bloom, where the boundary between known and unknown grows delightfully uncertain. An orbiter could study the storm systems that may churn invisibly beneath the cloud layers. It could investigate those mysterious auroras that dance in lopsided patterns, could measure the heat output of the planet's interior, that strange, faint warmth that Uranus seems to radiate far less generously than Jupiter or Saturn. It could study the composition of the upper atmosphere with a precision that ground-based observations simply cannot achieve, could perhaps confirm or refute the tantalizingly speculative idea that diamonds rain down through the depths of Uranus's mantle. And beyond the orbiter, there are dreams, not yet funded, but dreamed nonetheless, of atmospheric probes. Imagine a small spacecraft plunging into the clouds of Uranus, taking measurements as it descends, sending back data about the temperature and pressure and chemical composition at depths where no human has ever looked. It would burn up eventually, consumed by the heat and pressure at lower altitudes, but not before it had opened a small window into that alien world's secrets. The challenges remain formidable, certainly. The cost of such missions stretches into the billions of dollars. The technology must be invented or refined further still. The patience required to wait out the years of transit before any science can even begin demands a kind of long-term commitment that institutions sometimes find difficult to sustain. And yet the desire persists, that quiet, persistent human urge to venture further, to know more, to reach toward the dim frontiers of our own cosmic neighborhood. Perhaps what makes Uranus most appealing to explore is precisely this quality of mystery, this sense that here is a world we have barely touched, barely begun to understand. In an age when we have photographed the surfaces of Mars, when rovers trundle across distant plains sending back images, when spacecraft have visited every major planet, there remains this one great unexplored sphere, tilted, icy, enigmatic, spinning slowly through the cold dark, with most of its secrets still intact. To imagine a future mission to Uranus is to imagine a reopening, a moment when humanity turns its attention once more toward the outer solar system and says, not with urgency, but with the patient curiosity of a true explorer, what mysteries might we find if we looked more deeply still? If we were to pull back now, to drift away from Uranus itself and see it not as a solitary wanderer, but as one thread in a vast cosmic tapestry, we might begin to understand something profound about the architecture of our solar system and about the quiet distances that separate whole families of worlds from one another. Uranus exists not in isolation, but within a fundamental divide that shapes everything we observe in the space around our sun. Imagine, if you will, standing at a threshold. Behind you lies a realm of fire and stone and relentless heat. Mercury, Venus, Earth, Mars. These inner worlds, the terrestrial planets, spin in orbits so close to the sun that the light and warmth seem almost violent by comparison. They are sculpted by proximity, by the sun's fierce gravity pulling them tight, by the solar wind and radiation that strip away atmospheres, that forge surfaces of rock and iron. These are the small, dense, hard worlds, the ones we know most intimately perhaps, because they are within reach, because they are our neighbors in the truest sense. Yet they exist in a different universe entirely from the realm where Uranus dwells. Beyond the orbit of Mars lies something that the earliest astronomers could scarcely imagine, a vast emptiness punctuated by a belt of ice and rock, and then, far beyond, a different class of world altogether. Jupiter and Saturn, those giants of gas and turbulent storms, occupy a strange middle ground. They are immense, yes, but they are still relatively warm, their own internal furnaces still burning hot from their formation billions of years ago. Heat radiates from them constantly. They roil with color and motion. They are, in many ways, closer cousins to the violence and passion of the inner solar system than to the quiet, frozen regions beyond. But then the line crosses again. The distance widens further. The sun becomes a mere bright point in an increasingly dark sky, and the temperature plummets, as if crossing an invisible boundary into another realm entirely. This is where Uranus resides, in what we might think of as the realm of ice giants, a category distinct and different from everything that came before. The ice giants, Uranus and its neighbor Neptune, a world so similar in composition and yet so distant in space that they might almost be twins separated at birth, exist in a realm of profound cold and stillness. They are not fiery furnaces like Jupiter and Saturn. They do not roil with the internal heat those larger giants still possess. Instead, they are monuments to distance itself, to the fading of the sun's influence, to the slow, patient cooling of worlds in the deep outer reaches. And what is remarkable, what draws the contemplative mind to wonder, is how that fundamental similarity between Uranus and Neptune speaks to something about cosmic organization, about how the solar system is not a random arrangement but a progression, a gradient, a gentle sloping away from warmth toward cold. Uranus, with its tilted axis and its pale blue-green hue, and Neptune, with its deep saturated blue and its winds that move faster than anything in the solar system, might seem quite different when viewed up close. Neptune, after all, radiates more heat than Uranus does, another of those mysteries that scientists still contemplate. Neptune seems more active, more dynamic, more turbulent. Yet they are fundamentally kindred. Both are ice giants. Both orbit far from the sun. Both experience seasons that stretch across decades. Both exist in the same zone of profound cold and perpetual twilight. If we were to imagine the solar system as a vast concert hall, then Mercury, Venus, Earth, and Mars might be thought of as the bright, percussive sections in the front, vigorous and energetic and warm. Jupiter and Saturn, those gas giants, would be the full orchestra in the middle, powerful and resonant and still warm with their own internal fire. But Uranus and Neptune, they would be the strings section in the far reaches of the hall, moving in their own slow time, playing their own patient song, sustained and harmonious, distant from the frenetic energy of the central regions. This zooming out, this contextual understanding, reveals something almost soothing about Uranus's place in the cosmos. It is not isolated or lonely, as it might appear when viewed alone against the black void. Rather, it exists within a clear hierarchy, a logical progression from sun to shadow, from fire to ice. Everything it is, its composition, its cold, its slow orbit, its gentle moons, all of this makes perfect sense when you understand where it sits relative to everything else. The great distances between these worlds are so vast that they challenge human comprehension, and yet they follow laws as orderly and predictable as the laws that govern sound in a musical instrument. The further a world orbits from the sun, the colder it becomes, the longer it takes to complete an orbit, the slower its seasons pass. These are not accidental features, but consequences of the gravitational dance that ordered our solar system billions of years ago. And Uranus, in its tilted and icy stillness, is simply following those laws, simply occupying its appointed place in the grand architecture. One might imagine, drifting through that vast empty space between the orbits of Saturn and Uranus, how the sun's light and warmth would gradually fade. The brilliant yellows and golds and oranges that dominated closer to the sun would give way to cooler light, to deeper shadows, to the pale and distant illumination of a sun that has become almost like any other star in the sky. Temperature profiles would shift, colors would drain away, the pace of everything would slow, and then, at last, you would emerge into a realm where two enormous, icy spheres move in their long, unhurried dances. One tilted sideways like a cosmic accident, the other spinning in a more conventional manner, both colored in shades of blue and blue-green, both tremendously cold, both profoundly distant from the warmth and energy of the inner solar system. This is where Uranus belongs, not as an oddity or an afterthought, but as an integral part of a system that makes aesthetic and physical sense when viewed as a whole. The icy stillness that characterizes Uranus is not emptiness or desolation, it is rather a kind of quiet order, a patient orderliness that extends all the way from Neptune's dark and distant orbit through the realm where Uranus dwells. These ice giants are the sentinels of the outer solar system, calm watchers at the threshold between the warm inner regions and the vast, dark, incomprehensibly cold realm beyond, where only comets and dust and the whispers of the primordial solar nebula remain. And in that role, in that position, Uranus seems almost peaceful, a world perfectly suited to its place, moving in its own slow time, orbiting in its own distant rhythm, neither rushing nor faltering, but simply being. And so we begin our slow return, our gradual spiral back through the ordered spaces of the solar system, leaving behind that tilted world in its ancient solitude. Uranus recedes now, its pale blue-green sphere growing smaller against the infinite dark, its rings fading to the faintest line, then nothing at all. The great distance that separates it from the Sun, nearly 2 billion miles, becomes not a barrier, but a kind of quiet testament to its patient existence, spinning on its side through the cold centuries, while hardly anyone on Earth thinks to look its way. As we drift backward through the void, we pass Neptune once more, that deeper blue sibling even farther out, and somewhere in the invisible spaces between them floats the Voyager 2 spacecraft, still transmitting its whispered signals back across the vast emptiness. Long after it reached Uranus in that brief and precious encounter, it sailed onward, our only emissary to have ever touched the outer solar system and lived to tell the tale. What a gentle thought it is that human curiosity built something that could survive such a journey, could witness these distant worlds, and send back the gift of their images and measurements so that we might sit in the dark and imagine them. And now the distance closes, degree by degree. We pass through the asteroid belt, that scattered necklace of ancient stones that marks the dividing line between the giant worlds and the smaller, rockier spheres that orbit closer to the Sun. Here is where the solar system's architecture shifts, where the vast swollen planets give way to the terrestrial worlds, to Mercury and Venus and Mars and our own Earth, each spinning in their own rhythms, each held in their own careful orbits by the Sun's eternal, patient pull. Can you feel how the temperature would begin to rise as we approach, how the starlight grows incrementally warmer, less distant? The frozen methanes of Uranus's sky belong to another realm entirely, one of patient, deep cold and slow mysteries yet unsolved. Down here, closer to the Sun's heat, the worlds are different creatures altogether. Yet there is something deeply peaceful about remembering that Uranus is still there, is always there, spinning silently through its 84-year orbit, completing its seasons while we complete our own small cycles. What draws us to these distant worlds is perhaps the same quiet pull that draws us towards sleep itself, a recognition that existence continues in ways we cannot always see or touch, that there are mysteries unfolding in the darkness beyond our understanding, and that the universe is large enough to contain both our small lives and these vast, tilted, beautiful spheres of ice and atmosphere. We have spent this journey learning about Uranus not as something separate from us, but as a neighbor in the grand architecture of our cosmic home. Its sideways spin speaks of ancient collisions we can only imagine. Its methane hues reflect light in ways that create that gentle twilight blue we have come to know. Its rings and moons and strange internal warmth pose questions that may take decades or centuries to answer fully. And perhaps that is the greatest peace Uranus offers us, the peace of accepting that not everything must be known, not everything must be solved. It sits there, patient and real, completing its slow rotation, experiencing its seasons that last longer than human lifetimes. Its magnetic field drifts and tilts, creating auroras that probably bloom in colors we would find beautiful if we could ever stand in its atmosphere and witness them. Deep within its layers, perhaps diamonds fall like snow in endlessly repeating cycles. We do not know, and there is something restful in that acceptance. As we continue our drift homeward, imagine the solar system spread before you now in its full architecture, the Sun at the center, burning through its long, steady life, the inner worlds orbiting close and fast, their days and nights following in quick succession. Then the great planets, the giants and the ice giants, each keeping their distance, each following their own paths, and Uranus among them, the strange one, the tilted wanderer, the quiet giant that reordered our understanding of the solar system when it was first discovered. For so long, humanity thought the solar system ended with Saturn. For so long, we looked up at the night sky and saw only what we had always seen, not knowing that beyond the reaches of our ancient telescopes, beyond what generations of humans could perceive, this patient, rolling sphere was already there, waiting. The journey back to Earth continues, slower now, almost languorous. We have learned that Uranus carries within its quiet form 1,000 questions. We have felt the strange sideways spin that makes it unique among all the planets in our system. We have traced its rings with our imaginations, met its moons with their Shakespearean names, wondered about the mysterious dimness of its internal heat and the possible rain of diamonds falling through its frozen layers. And now we carry all of that knowledge with us, back toward our own world, back toward warmth and gravity and the familiar hum of daily life. But Uranus remains out there still. It will continue its long orbit, slow and steady, asking nothing of us except perhaps that we remember it occasionally, that we acknowledge its existence, its strangeness, its particular beauty. It does not demand exploration. It does not cry out for attention. It simply is, patient and tilted, orbiting through the cosmic dark in a rhythm that spans nearly a century for each complete circle around the Sun. And as we draw closer to Earth now, as the third planet from the Sun begins to resolve itself into detail, into the continents and oceans we know so well, there is something deeply comforting in knowing that Uranus is still there. Distance does not diminish reality. Remoteness does not make something less true. All that we have learned tonight about that far blue-green world, all the mysteries we have explored and the facts we have gathered, remain constant and real, waiting in the dark, unchanged by our attention or lack of it. The solar system encompasses such vastness, such complexity, such patience. Uranus is one piece of it, one strange and tilted piece, but a piece that has held light and mystery, and the wondering thoughts of astronomers and dreamers for more than 200 years. From the moment William Herschel's eye caught sight of that greenish disk in his garden telescope, to this very moment, it has been teaching us about the limits of our knowledge and the rewards of looking beyond what we think we already know. And now the return is nearly complete. We can almost feel the warmth of the sun on our skin once more. We can almost sense the presence of the moon, our small, close companion. We are nearly home after our long drift through the outer solar system, our encounter with that beautiful, enigmatic world of ice and tilted rotation. So carry Uranus with you now into your own stillness. Let it drift in the back of your mind like a half-remembered dream, a blue-green presence in the cosmic dark, a reminder that the universe is far vaster and stranger and more wonderful than the small circle of immediate experience that surrounds us every day. Let the strange peace of that sideways spinning world settle over you now, with all its unanswered questions and all its quiet, patient existence. Tomorrow, if you look up at the night sky, Uranus will still be there, not visible to the naked eye perhaps, but present nonetheless, real, spinning, orbiting, slowly completing its ancient dance around the sun. And somewhere in your memory of this journey, in the layers of your own mind, you will carry with you the knowledge of that tilted sphere, that ice giant, that quiet wanderer that waits in the dark, patient as only the cosmos knows how to be patient, gentle as only the infinite can be gentle. Let yourself drift now, deeper and deeper, away from the outer solar system and toward your own rest. The solar system recedes, the stars blur softly, and in the darkness there is nothing left but silence and peace and the vast, steady breathing of the universe around you.